Okay, this is the CET236 homework 5 for superposition, and I thought I'd go through it. So part 1, how many subproblems? Well, we've got 2 sources, so there's 2 subproblems. Remember, the aim of superposition is to figure out the effect of all the independent sources on the rest of the circuit individually, and then combine them at the end to find the complete solution. Right, so here we have VS and IS, they're both independent sources, and we need to basically make 2 circuits. One that keeps VS and replaces IS with its ideal source, which is an open circuit, and one which keeps IS and replaces VS with its ideal, which is a short circuit because it's a voltage source. Okay, so let's see what the next part is, the subproblem. So first of all, we've got to analyse the effect of VS. And what we're trying to find in the overall thing is the output current here. So let's just figure out what the VS circuit looks like. So it's going to be the VS, we'll keep it, and then we've got R1 and R3 and R4, and we're going to have R2 here, and the thing we want to find is I out. Now R1 is 10k ohms, R2 is 6k ohms, R3 is 8k ohms, and R4 is also 10k ohms. Right, so how do we do this? Well, we could combine R2, R3 and R4 into a single equivalent resistance, figure out what the voltage at this point A is, the voltage between the 10, 8 and 6k resistors, and then we could figure out the current through the 8k and the 10k by that voltage. So what do we do that? So the equivalent resistance is 10k ohms plus 6k ohms in parallel with 8k ohms plus 10k ohms, because R3 and R4 without IS are in series. And I forgot to, I know I do have MATLAB running there, so let's grab MATLAB and let's see if we can't just put that calculation into MATLAB, and we'll do that here, and I might just see if we can make that a bit bigger so we can see it. There we go. So the R equivalent, Q1 R equivalent equals 10,000 plus 1 on 6,000 plus 1 on, and I'm just going to go 18,000. I'm not going to add them up. There we go. So there's our equivalent. And then the voltage, VS, is 26 volts. So the current, sorry, we want the voltage at A. So the voltage at A, so we call it Q1 VA, equals, it's going to be the 26 volts times Q1 rec divided by Q1 rec plus whatever R1 was. What was R1? R1 was also 10k. Right, so there's our V1. So our I out 1 is going to be Q1 VA on 18 kilo ohms. So let's see if we can save that. I should save it in my right, so this is homework 5, superposition. Oops, it doesn't like that because I didn't call that one correctly. Right, so we've got what's that? That's 0.854 milliamps. Right, so what did we get? Actually, let's just go back and grab the Q1 VA is 15.39, and actually let's get the Q1 rec. That's 14,500 ohms, right? So that's 14,500 ohms, and our VA was, what did we say VA was? 15.39 volts, and our current was 0.8549. Milliamps, or 0.308549. Let's just check to see that that's 0.308549, and the see if that comes out correctly. Ooh, it didn't. Let's check my answers. See what the. Ooh, it's out by a factor of 2. I wonder why that is. Let's oh, I think I know why. Okay, so the answer is going to be oh, I know why. I got my calculation wrong, right? So we've got the VA. Well, do we have the VA correct? I don't think we do. Let's just go back and see what I typed in MATLAB, right? To get VA, I did that, and that's not correct, right? I've got that wrong. My VA is actually this piece, so the equivalent, oops, let's see if we can't do that. So it's got to be the equivalent of these pieces divided by the equivalent resistance. So let's just oops, see if we can't get that eraser going, and we'll get the right answer here. I'll actually should have written it out correct fully. So let me oops, grab all of that and maybe delete it and grab some more stuff maybe. Don't know why it doesn't select and stay selected. Okay, so then we can get that. Right, so now what we want is VA equals the 6 kilo ohms in parallel with 8 kilo ohms plus 10 kilo ohms, right, divided by REQ, which is the 10k plus the 6k, etc. So let's and then we've got to multiply that by the input voltage, which is 26. So let's do that in MATLAB, and then we should get the right answer. So where's MATLAB? There we go. So we don't want that. we want this piece of it, right? So we want that divided by Q1 rec, and that should give us something more sensible. And let's just run that and see what it gives us. Yeah, that's more like it. So now our Q1, our VA is 8.069, right, which is 8.069 volts, and our I01, what was it, is 4.483, 0.4483 milliamps, or 0.30 4483. And so 0.000448 amps. Now let's see if that gets the right number. Okay, we got the right number there. Now we've got to figure out how to get the other one. So let's go do that. So let's do the other one. Right, so the other one, oops, looks like my OneNote has decided to go away on me, so let me just try that. So what did I say the VA was? The VA was 8.069. And the I out 1 was 0.4483 milliamps. Okay, so the other circuit is going to be where we keep IS, and so we've just got a short instead of VS, so we're going to have is R1, it's going to be in parallel with R2, and then we've got R3 and R4, and now we've got our IS here. Let's just see what that does. So it's IS down. So again, we've got our 10 kilo ohms here, we've got our 6 kilo ohms here, we've got our 8 kilo ohms here, and we've got another 10 kilo ohms here. Now, and we want to get this one I out too. So how do we get that one? Well, I think I'm just going to do it as a current divider, right? Because we've got the 8K, the 6K and the 10K on the left hand side as one equivalent resistance, and we've got the 10K on the other side. So let's just group these three together, and let's call that REQ2, and that's going to be 8K plus 10K in parallel with 6K. And we'll have to figure out what that is. Let's go back here, do that. Right, so we'll just put semicolons there. So REQ2, what did I say what it was? I said it was 8,000 plus 1 on 10,000 plus 1 on 6,000. Right, so there's our REQ2, and then the current. Now it's going to be the negative of this, so I out 2 is going to be minus IS, which was 3 milliamps, 0.003 times the current, the resistance in the other branch, REQ2, divided by the total resistance of both branches. Right, so it's going to be something like that, and I'm just going to see if that works. Right, so 11,750 and minus 1.62 ohms. So this is let's grab that. So it's going to be 11,750 ohms, and our I out 2 is going to be minus IS times the resistance in the other branch divided by the resistance in the other branch plus the resistance in this branch, and that gets us to minus 1.621 milliamps. Let's see if that works. Yeah, it looks like it's going to go. So minus and it's 0.001621, and that's amps. And hopefully that'll be close enough to the real one to match. And then the total is just going to be the addition of those two. So, where's it got? MATLAB, there we go. Right, so our I/O, let's just close those over, and I/O for Q1 equals I/O1 plus I/O2. And let's run that. So that's minus 1.172 milliamps. Minus 0.001172 amps. And there's everything green. So I'll kick off another